Okay, so what we're going to look at here is seasonality and the seasonal indices, and basically how we can use a seasonal index to help us analyze our data. So basically what we've got here, it says here, a seasonal index indicates how a single season compares to the average season. So our first step in calculating the seasonal index is to work out the value for the month, use a value for the month, sorry, and we divide it by its seasonal average. Now that seasonal average can be in the form of a monthly thing. So you'd be looking across, bunches of 12 months, quarterly. So, every quarter, so you have 4 quarters and you'd have it over a number of years and you use it in that sort of format. Okay. The sum of the seasonal indices is equal to the number of seasons and the average of the seasonal indices is 1. I'll go through an example of this shortly. What we've got here, an example of examples of inferences from seasonal indices. So what we've got is, if it's a seasonal index is 1.4, it's indicating that the data was 20% above average. If it was 78%, it's 0.78, that basically means it was 22% below average. But over the whole year, you'd find that everything sort of averages out. Okay? And then what we can do with the data at that point is actually deseasonalize it. Okay? In deseasonalizing it, what are we doing? We're modifying the data so that we can remove the variation that's caused by the seasons. And this is what's done here. You can see this one, that's been seasonally adjusted, so it's been deseasonalized, that red curve. You can see it's a lot more, it's got a lot more shape to it, that you can see what's going on as opposed to the actual data. All right. And when we do that, we find that we can have this equation where we go deseasonalized value, which is that one, equals the actual value. Oops, that should have been green. Okay. Divided by the seasonal index. And that's the I there. Okay. And this is just pointing out this part here about the seasonal index. It's clearer now, obviously, about the deseasonalized data. We can see there's an upward trend in unemployment figures over 5 years after the seasonality has been removed. Okay. So what we're going to look at is an example. We've basically talked about seasonality. We say it's seasonality if there's a regular pattern of rises falling across the time series. But when we're going to deseasonalize and look at it in this way, you're going to do it for more than 1 year. You're going to look across a number of years so you can get an idea. And here's just an example. This is an example of quarterly sale of cars over a 3-year period. Okay. We can see that there's some sort of pattern there, but we're seeing it going from here up to there, then drops again. So in first quarter it's slow, then goes up to high, then it drops down in the next two. Then it does it again, starts slow, goes up high, drops again, then starts slow, and that's the seasonality. Now, what we're going to look at here is how to calculate the seasonal index. So first off, you've got in this case, you've got your years. I think I said 3 years, it's 4 years here. So I've got my years here. All right. And in using with those years, you've got the 4 quarters. Okay. So that's like the first 3 months, second 3 months, third 3 months, and the last 3 months of the year. What I do is, I know it looks a bit fuzzy there, but basically I add these 4 numbers and then divide it by 4, like any type of average. And in doing that, and let's have a look at one where it's a bit clearer for you to look at. This one here, just because it's down the bottom, I've added 253, 471, 389, 325, and I divide that by 4, and I get an average of 359.5. Okay, you do that for each year. You want to get the average for the year. Then what I do is this is where I can start to work out what is the seasonal index. It's the value of the season divided by the average, that seasonal average. So what I'm going to do here is I look at, say, which is example they've used quarter two. And they're going to go quarter two, which is, that's my value for the season. My seasonal average is that value there. And I calculate that. I get 1.4270. And you can see that that's where it is there. So you do that for each of these. You go across. So you'd go 202 divided by 277.5. Then I've done that one. Then I go 274 divided by that. 238 divided by that. And then I do it again for 1997. Go across. I get the average. Then I go 212 divided by 261.5, etc., etc., etc. Okay? And that'll give you something that looks like this. All right? You get the data like that. Now, if I added, just to sort of highlight, if I added each of these together, I would get 4. If this was done over 12 months, I'd get 12. If it's done over a 7-day week, I'd get an answer of 7 if I added up those indices across there. Okay, that's just to sort of highlight what that means. You know, sometimes you'll get questions, especially in exams where you've got to work out what the missing seasonal index is. And so if it's done over 12 months, you need to know that, you know, for one for each month, if there's a missing one, that total is 12. So you work it out based on that. Okay, so what I'm looking at here, quarter one. So I want to get the index. I want to get the basically the average for the seasonal index for quarter one. So basically, I add each these together, divide by 4. In this case, I get 0.818. I'll do the same for quarter 2, quarter 3, and quarter 4. And what does that give you? That gives you indices as shown here. So quarter 1, 0.818, quarter 2, 1.505, quarter 4, 1.145, and so that's quarter 3, and quarter 4, 1.041. Now this is what I was saying before. This is where you'd actually do it, not so much above, but same point being that if I add those up, I should get 4. All right. And this is again what I was saying in the earlier page. Sales in quarter 1 are only 81.8% of the average quarter, whereas in sales in quarter 2 are 150.5. So this one's saying 20% less and about 50% more than the average. This is where we start to make predictions, and this is where you use your knowledge from the stuff we've done with linear regression lines. That's where you'd use it. Now, before I do that, I want to make a point that I deliberately ignored just while I was talking about it up here. I did it for a reason, because I wanted to sort of continue with the train of thought before. But what we've got here, what I've said here, is you've got to give this data a time code, because if I ask you to make predictions for 2000 or 2001, you need to have an associated time code. So in this one, because we're talking about 1996 at quarter 1, I can't put that in the calculator, so I'll give it a time code. So I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 10, 11, 12, 13, 14, 15, 16. And that's my time code. So that's what I'd go with the time code here. So I'd go 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So now later on, when I want to know quarter 3 in 2000, that's going to be 17, 18. It's going to be 19. I'll use a time code of 19 to correspond to the third quarter in 2000. We'll use that again shortly, which is why I just wanted to bring it up there. Okay, so at this point, we actually want to deseasonalize the data because as we noted before, the idea is to move any variation that can be explained by the seasons. Okay, it makes it easier to see the trend, and that's what we do here to get the deseasonalized figure. So the deseasonalized value. So remember that's D, that's A, and that's I. We use this equation here. We get our actual figure and we divide it by the seasonal index. Remember, our original figure was 202. Okay, so what we're going to do is we're going to go 202 divided by 0.18 because it's in quarter one, and I get 247. Then I'd go this one here, 253. So I'd go like 253 divided by it's still 0.818, and I would get an answer of 259. Oh, hang on, which one am I looking at? It'd be this one here, sorry. My answer would be 309. Okay, then I would do it for quarter two. Quarter three, it's like saying 274 divided by 1.145 because that's quarter three. So just to sort of show you what I mean, that's saying this one's match up. That's where I'm going to be using my values. Okay, so this is D here. This is I, and this is what we call it, A for actual. That's where you're getting your data from, how you're using your data. So you do that for each of those and you'll get your answers. So this is my deseasonalized data. Okay, and this is what you end up with as a result. You end up with, as we said before, this was your actual, and this one here is your deseasonalized. Oops, I can't spell properly. Deseasonalized. Okay. And we can see there's a slight increase, over time that sales are increasing. Now, what we can do with that is we've got a line that we can conveniently plot up. So what we're going to do is we do a line of best fit. That's that green line here. This is my linear regression line. And that is that value. Now that linear regression line is pretty much what you've done previously. It's doing a linear regression line. Notice I'm using my time code here. It's got the time code. Okay, so now if I wanted to, I could predict based on information, time code 8, so 1998. It would be 1998 in quarter. Hang on. No, it wouldn't be. It would be 1997 quarter 4. I could predict that, but I put quarter number here. So this is my version of time code. All right, so I just put 8. Now, what you could be asked to do is actually work out, I want to extrapolate my data. So I want to do, I think I said 19 before, so it would be 19, remember this is 16, 19 would be quarter 3, 2000. I'd put my time code, my associated time code there is, it's what I put here, D, no, I've put it in the wrong spot. That should be 16 and 19. So I've got time code 19. I'd put time code 19 in there and I'd calculate it. So it'd be like 217.3 plus 7.1 times 19. That'll give me a value. That is my predicted number of cars sold using the deseasonalized linear regression line. You got to remember, That's my deseasonalized value. What you then do, and it doesn't show in this particular example, what you then do is you need to use a different equation at that point. Well, you use the equation you've got up here. So at this point, I can predict number of cars, or whatever it happens to be in your example, using, let's put deseasonalized data. Okay, but the reality is you want the actual data. Okay, and remember that there's an equation we talked about previously, this one here, D equals A over I. So basically I've got, let's pick that, I've got D equals A over I. I'm actually after A now. This is the actual data is this. So my equation becomes actual data equals D, the deseasonalized data, times its respective seasonal index, which is in the example I've done here. It's saying plot it. I've plotted the data, fitted, so this is, in this case, the D is already deseasonalized. Okay, so you fitted the data, sales blah, this is what your equation was. You could talk about what, talk about your y-intercept and your slope if you wanted to, if you got asked that. But what you're really doing this is, and this goes to this part here, but what you're really doing here is predicting, say for example, the winter of year 4. So they're saying that's winter would be winter of year 4 is quarter 15. So my time code for this one, for this equation here, that's where you'd have as 15. So I'm extrapolating past where my data is, but this is deseasonalized data. And I calculate that, and so I say, oh well, this is my sales I'd expect to get. But that's taking seasonality variations away. So this is deseasonalized sales. So to get the actual sales, I use this equation as I said before. You put those numbers in, you rearrange it so it's in terms of actual. You want it as actual. So it becomes, so you're using the seasonal index here for winter. And you'd go actual figure equals deseasonalized figure times seasonal index. And that is your value. Okay. I think that's probably enough for now. Okay, thank you. Bye.